18th. We have a code of conduct, which we found on our website, that generally encourages a friendly, welcoming environment for people from all backgrounds and all skill levels. So we're hosted, you can see by MATLAB, who hosts us every Thursday. MATLAB stands for the Mobile App Development Lab, and they initiated that 3D printer also run all sorts of events. We also have, if people like to get instructed, get involved with decoders, but any of the execs know. So I'm an exec, and the execs can.
Yeah, close to us,
right? About this at any point. Finally, this is the first of a brief series of Python workshops. I forget what next week says. I believe it's some sort
like
of
data packages or
yeah.
statistical workflows, something.
Right. It's being done as
data analysis workflow.
Okay, we sort of got the close.
Yes,
yeah.
we got close.
Yeah.
So we're gonna have more Python lessons to come.
Yeah.
So we usually start off our lessons with brief introductions, who we are, maybe how comfortable we feel with the source material, whatever you feel like. Elements. So my name is Ahmed. I'm a second-year PhD student with cell systems biology, and I'm a big fan of Python. I started using it about 2 years ago, and I've grown to use it a lot in grad school. And relatively comfortable with it.
Oh, we're going to
Yeah, we're just gonna go around the group. Yeah.
Oh, hi. My name is Yan. I'm a first-year PhD student in the pharmacology department. I work up at Sunnybrook on some genetics and imaging data, so
Cool.
I would love to learn more about different coding languages.
Sure.
So I'm here.
I'm Nana. I'm a fourth-year PhD student, but my knowledge about coding is really basic, so I hope it's easy for me.
Yep. Yeah, that's great.
I'm Heidi, second year, PhD, pharmacology as well. R, Python,
And yeah, so I'll start. So I'm Lena. I'm a fifth-year PhD student now in physiology, and I use Python. I've known Python since I started I learned it while I was in grad school, and I'm pretty familiar with it now. So hopefully I can teach you some little tips and tricks that'll get you started. You're not going to be a pro by the end of this lesson. I can't promise that, but you'll just feel a bit more familiar with the kind of the language. Okay, so if you have your Jupyter Notebook open, one thing you'll notice is I have like this text box that I made. And what it starts off is I clicked on it and I clicked on it. So without being in the box, I clicked on the outside and I clicked M to turn it into a text box, just to write little notes to myself. I mean, this isn't really a note, it's a title and some information, but you can write little notes as you go. So if you wanted to, for example, turn this is a code block, you can tell because it looks like this, but I can turn it by, again, clicking on it, pressing just M, and it becomes a text box. Try that out, everyone's okay with that, it's working? No, it's not changing? Oh yeah, and you can make a new box by pressing outside, click on the white space and click B to make new ones. Do you getting new ones? Okay, and they should automatically by default be code blocks when you first make them. But then if you click on one just beside it in the space here, I can click M and it becomes this, and I can type little notes for myself like, we are going to work with integers, with math. We're going to do some math, for example. Does that kind of make sense? So if you want to start in between, just like add a couple more chunks, get them ready so that you don't have to keep adding them while you're typing. That's what I tend to like to do. And if you want to change it back, you accidentally made this a text. Let's say I do that, I make it M. I click M and then I turn it into a text box, but I want to change it back into a code block. I can do Y. Okay, so you just kind of have to remember these little shortcuts. Yes, thank you. Okay, so when you're starting with Python, it's kind of good to know just kind of like the basic bare bones of what it can do. And something that's going to be useful as people who are working with data often, we need to do math with it, right? So I'm just going to show you how math works in Python, and it's pretty intuitive and readable. So for example, in my first code block here, I'm going to click into it, and I'm just going to do 2 space plus space 2, and then Shift Enter to run it. That makes sense? So you press Shift Enter together while you're in the box, it'll actually run it and it gives you an output. So this is what, so it says what goes into the program is 2 plus 2, what comes out is the answer 4, right? pretty straightforward. So that's addition. You can do, subtraction. I won't show you an example of a subtraction, but it's the same. You just use a minus sign instead. You can do multiplication. Multiplication uses the asterisk. So 2 star or asterisk space 2 is going to give you 4 also, right? If you want to do to the power of something, you could do 2 double asterisks space, let's say 3. 2 to the 3 is 8. And one thing to note is the spaces are more just for us to have more readable code. White space does matter in Python sometimes, but for now, we're just adding spaces in between these things just to make it look a bit more readable. Imagine if I did this, it looks kind of a bit crammed together, right? So just for us to make it more readable, we're gonna, typically you would add spaces. And I'll show you a bit later where spaces really do matter. Okay, so that's just basic math there. It also follows like BODMAS or BEDMAS, the order of operations. So if you did like 2 minus 3 to the power of 4, you'd get 1 because it's -1 to the power of 4. Okay. So now these are all integers, but there's an important thing that we need to note is like when we do math with decimal points. So it changes actually the results you might get sometimes. So here, I'm just going to scroll down. I'm going to make a few more boxes by clicking out and then going to click back in. So in Python, numbers with decimals are called floats because they have floating point numbers. They are floating point numbers. So let's, for example, do 2.0 times 3. Or let's just do times 2 to keep it the same. And if I press Shift, Enter, I'm going to get, notice that this 2 times 2 here looks different than 2.0 times 2. It turns the output into a float as well. And that just has to do with Python's ability to maintain precision. So if these are integers, so they don't actually have any points. And so you can encode it in memory as, I think, just 8 bits or something, like within an 8-bit system or a bit system. Whereas when you have the floats, it changes the type of number that it is. Okay. So if we did, for example, 2.5, 2.6 times 3, again, you're going to get a float as a result, right? Okay. So now we have like a basic idea of the math. That's probably just for you to know that you can do math and you're going to need to at some point. But usually we're going to be working with variables, right? You're going to get data that has different columns and rows, and you might want to store things into a variable. And a variable just is like a container for information. And you can have numbers inside your container. So let's make a variable here and call it year is equal to 2019. So it can store the year 2019. And I'm also going to put my name is equal to Lena. And notice that we've been working with numbers, but here I just made something called a string, and it needs to have quotation marks around it. A string is just text. So here I have my name, Lena, inside 2 of the same type of quotation marks. Here I'm using single quotes. You can use double quotes. We're not going to distinguish them here, but just always use the same type. And I'm going to again press Shift Enter. So nothing happened, right? Why doesn't nothing happen? Because we didn't actually ask the computer to print out anything or to return anything to us. We just stored something in a container, right? So it stored it. We can now check whether or not it actually did that. So there's a handy dandy function in Python called print, which can tell you what is stored inside a variable. So you don't actually, so you can actually do, print will actually just print out whatever you put inside it. But if you put a variable inside it, it'll actually tell you what's inside the variable. So if you press Shift Enter there, you should get the actual, it won't type out the words year. It'll actually print out what's inside year. Does that make sense? And if I did the same thing for print name, it should have my name without the quotes. And I can also do, notice one thing is if I actually give it like my name in quotes, it'll actually act as, print it out again, like it'll execute it as a string and print out my name, okay? So if I wanted to know what is the type of item that is stored inside my variable, let's say I made this code a year ago and I want to go back and say what is inside the year variable. or like what kind of value is there. You can see that it says, if I do print type bracket parentheses, year, you get the class is the integer because 2019 is an integer, right? And if I did the same thing, print parentheses type parentheses name, it's what I said before. str is short for string, which is what we were talking about before. So Python can deal with lots of different types of data. So imagine you're working with, so you're saying you work with GWAS. So a lot of them might be like strings of like nucleotides or something, or not nucleotides, but like strings of text, right? Yeah, genotypes, exactly. So you're going to have strings as your input. So you might need, so there are things that you can do with strings, and there are things that you can do with numbers. So it can take lots of different types of input. We're not going to go through all of them now, but just know that there are different types of input that Python can work with. Okay, and if you ever want to know, so we use this function. I told you that print does prints out what is inside these things, what is given inside of it. But if you wanted to know what it does, you can always use the help function, which looks like this. You literally just type help, 2 brackets, and inside write the name of the function that you're curious about, and it prints out the instructions on how to use it. So if we look at it, we see help on help is built. It tells you that the print function takes a value and a couple of other things, and it prints out the values to a stream. And these details aren't that important, but basically it prints it out for you at the end. Okay. You can imagine as you get more, as you start using more and more functions, you might see online that you need to use this function, but you actually don't know what it is. You can actually just type it inside and see what people wrote about that function to help you use it. Okay, so we have an idea of the kind of data that we can work with. We made some variables. An important thing that we might want to do is store multiple variables inside of something, and that's called a list. So instead of just storing one thing to one named variable, you can make a list under the same named variable. So let's just make a list called fruits. And the reason I'm calling it fruits is because I want it to be descriptive of what I'm going to store in it. So how we do this is we have fruits and equal sign. Sorry, I didn't mention before that that's the basic part of how you make variables is you have an equal sign, the name of the variable, and then what's stored inside it on the right? The equal sign just tells us we're putting this inside the thing on the left. So fruits is going to take a list, and how you make a list is you have the square, the brackets. So do that, and then inside we're going to fill it with some fruits, which are going to be strings, text, right? And inside the first one, I'm going to type apple. And notice that I think in Jupyter Notebook by default, it should always autocomplete the second pairing of, say, a bracket or a apostrophe. So that's pretty helpful. So notice I clicked it once and it made 2, and it puts you inside. So you can start typing. So I'm going to do orange. So just type along with me for now, and I'll explain a bit more. Just say mango. Okay, so I have a list, which is comprised of these square brackets and then items on the inside. These items are strings in this case, but they don't need to be strings. We'll talk about examples of doing them with different items later. And notice that I named it fruits because I actually want my variable name to be pretty representative of what is going to be stored inside it, right? So say you did have genotypes, you would probably want your variable name to be like genotype or something descriptive. So when you go back and look at your code, you're going to know what's inside of it, or like what you're writing about. So so press Shift Enter on that just so it saves it or like executes it. And then we can use that print function again to take a look at what's inside of it. So print fruits and press Shift Enter. And then it basically spits it out exactly as is. So that's pretty standard. That's not that interesting. But what if I wanted to actually, let's not get into that yet. But I said before that in this case, we're using all strings. We can also make a list that is not all strings. So let's just make it a miscellaneous misc list and do an equal sign. You always need the square brackets to make a list, right? That's how Python knows you're about to make a list. And I can do something like Python with like a phrase and then comma, right, to separate the items. And then I can do a number, 42, And I can also do a float like 42.5. And if you shift enter, it should have saved that in there. And if you print MISC, it should have all those items there. Okay. So just to break down the syntax or the way this language is made for lists, you have the variable name, you have the equal sign, and then on the right side, you have what's inside the list, which is made up of these square brackets and the items inside separated by commas, and typically a space just to keep it nice and organized, or like nice looking. Okay. So I'm going to do something. So I have fruits. What's an interesting thing about lists is you can add them. What do you think that does? If I do fruits plus fruits, just take a guess. Anyone? Well, how about we both write it? Oh, sorry. No, actually it won't. So both. How about you guys write that and press shift enter and then let's see. Fruits plus fruits. It'll actually just take one list. So fruits is one list and fruits is, we just happen to use the same list again. It'll take the first list and append it to the end of the second list and make a bigger list comprised of the elements. So what if I did fruits plus fruits plus MISC? So I'll get apple, orange, mango, and then the items of the miscellaneous list, which is Python 42, 42.5. So that might be really useful when you end up with two lists that you realize actually need to be concatenated, and then you can just simply add them. There's just another interesting thing that you can do with lists. Okay, so that's good. We can make lists, we can add them, we realize that we can do different things, we can put different items inside, different types of input inside. But what if we want to access, we made a list, we want to access an item in the list. So that's called indexing in Python. So how we do that is, let's start with our print. We're going to print out the first item in our fruits list. So I know I want the first item. And how we do that is we type out fruits. Then we use, with no space, you need the square brackets, and then put the number 0. Just press shift enter, and then it gave us apple. So this looks kind of weird, but the 0 tells us that we want the first item. And in Python, numbering starts from 0. So 0 means the first item, and then 1 would then be the second item, 2 would be the third item. So that's something that we always have to remember. It's a little bit different from, say, R, which starts at 1. Okay, so fruits is the name of the list, and then we need to use these square brackets, which often indicate that we're going to start indexing. We're going to start accessing individual items within our list or whatever you're indexing. And then inside the square bracket, or the brackets, you put the number of the item that you want to access. Okay, so if we just change that to 2, that should give us mango, right? Which is the last item. Okay, so if we wanted to get multiple items from our list, we can do that. There's a couple of ways. Let's just show you a couple of ways to do that. Fruits, square bracket. So we're using the print function, fruits, square bracket. And let's say we want up until the last item, so the first 2. So we can start at 0 and go up until the last, which is using this colon. It says 0 until, but not including the third item. If we print that, it'll give us apple and orange, but not mango. And what you can also do is you can actually just skip putting a 0 if you're doing that. And it assumes that you're starting from the beginning of the list. Okay, so that just saves you one keystroke, but sometimes it's just nicer. So you're going from the beginning until the end, and not including the actual end item. Okay, and if you wanted to do print fruits, if you wanted the last item, there's a couple ways you could do it. You could actually say, like over here, we did number 2, which is the third item. We could also do -1. Okay, that just means go backwards from the end of the list and take the last item. -1 gives us mango as well. And you can keep going. You don't have to use just -1. You can go 2 back and use the second last item. and do that by -2 will be the second last item, and etc. You can end up getting the first item by doing -3. Okay. Let's see what happens if we do -4. There actually is no -4. So it would say the list index is at a range. So what happened here is that an error popped up. I was trying to access the -4th item, which means 4 back, but we only have 3 items in our list, so it's not actually going to work. So index errors actually happen a lot when you're, that's an error I seem to get a lot. And often that's when you're indexing, you're trying to get an item that doesn't exist in the list in the index, if that makes sense. But let's go back to -3 and we'll get Apple again. Okay. So, let's see. Okay. So one nice thing about lists is they are mutable, which means you can change their contents after you've already made the list. So over here at the top, we all made this list called fruits, which had apple, orange, mango. But what if maybe this was like a grocery shopping list that stores automate and make them for themselves. But then you realize you don't actually need mango, you need bananas. So you can go in and actually use your indexing and also variable assignment together. So we're going to use fruits. And remember, indexing uses these square brackets at the end. And we know that mangoes is our third item, which if you go backwards is actually number 2. If you count back 1, is actually 2. And we're going to put an equal sign. So it's as if we're putting it in, we said before that the equal sign says we're taking a value and putting it inside what's on the left side, right? So we're saying in the spot, that is the third spot of fruits, put banana instead of mango. We're going to press Shift Enter. And if we print parentheses, fruits, it'll now have apple, orange, and banana. Is everyone okay so far with what we have? Okay. Any questions about this generally? Okay, so this is pretty useful because if things are constantly updating, if your data is constantly updating, you might need to like change your values and things like that. Sorry, I'm just gonna see what the next bit is. Okay, so we can index lists, but indexing is not a principle only for lists. We can index other things too, like strings being text. So what if we made a new string called sentence? So we're going to write a sentence is equal to, right? And then we always need our quotes to let Python know we're about to write a string. And we'll say this is a sentence. Shift Enter. So inside sentence, actually, if we print the type of sentence, it should be a string, right? Yeah. And so notice that we can use the exact same notation for indexing to access different items in our sentence. So if we print sentence and then we use that, we use the brackets again, and I want to go from the first until the 5th character, it'll be at the character level now, right? You will get this. And there's probably a space also that I'm not getting. Let's do, actually no, let's do that. This is. So what it does is it takes sentence, which if it breaks it down is made up of these individual characters. And then it says, well, now this is in spot 1. This is at index 0. This H is at index 1, index 2, index 3, and so forth. And then it'll access them that way. And this is actually called slicing when you use the colon. That might be useful to know that indexing, but slicing specifically because you're taking a slice of what you have continuously from start to finish. Okay, so you can also reassign this as well. Just like we did, we replaced banana in the list. We can replace a single character or a set of characters inside our sentence. So we can do sentence of, let's say I want to say, how many characters is this? 1, 2, 3, 4, 5, 6, 7, 8. I don't know how this will work. But sentence of -8 until the end. we'll see. We'll see what happens. Sentence -8 is till the end. Instead of this is a sentence, this is a sandwich. You can replace this. Sorry. String object does not support. Oh, right. This doesn't work. Sorry. Wait. Not work. Oh, yes. This is specifically why I did this, is because this actually doesn't work. So it's a list. A list can support replacement. Changing the items inside it, but a string, for example, won't have the same ability to change its items. Once you make a string is set, basically. Okay. Okay. So so you have to kind of remember like which types of data Python can do certain things with, and when it works and when it doesn't work. So it's good to, and you can always just try, right? If you try and it doesn't work, then now you know. So it doesn't hurt to have tried this. Okay, so there's another type of data, what am I trying to say? There's another type of data type in Python called a dictionary. And dictionaries have keys and values. So let's make one and we'll take a look at what it actually looks like. So I'm just gonna make more code blocks, code chunks, and then we'll call it fruit underscore colors. You can imagine what is going to be inside. So I have the equal sign to denote that I'm setting it into the fruit colors variable name. And then I have the curly brace. So inside, I'm going to write make a string and call it banana. And then that is my key. And then right after the key, you put a colon. Then you can put a space. Here I'm going to write banana. The color is yellow. That's what I'm trying to say here. But I can put multiple of these. So if I put a comma here, I can make a new one. You can actually press enter here. Notice that it press enter twice, and it should give a new line. I'm just going to go in and type. Just to keep it nicely separate, nice and readable, I'm going to put apple on the next line. The comma is important, right? Because that's how Python knows that we're making a new item within our dictionary. So here, the key is apple, and the value I'm going to give it is red. Apples can be many colors, but let's just say red for now. And then press enter again after you make a comma, and I'm going to do the last one is orange, and this orange is also orange. Okay, and notice that on the very last one, I don't need to put another comma, right? Because there's no more items. So just sort of like, think of it as a sentence. Okay, so press shift enter. If you have errors, one thing you might, maybe you missed a comma, you missed, everyone's good? No errors, okay. Okay, so basically what fruit colors does is makes a dictionary where you have these keys, which are the items that you would look up, and it gives you a value associated to the key that you're looking up. So for example, imagine this, you needed to know in our stock, what color are the apples? In this case, it's red, but we already know that because we wrote that. But if we didn't have, we only knew that we made this list of this dictionary a long time ago, we could access it like this. So we can print just like before. And then inside we'll write fruit colors, the name of the dictionary. And then in brackets, sort of like indexing, but this time, instead of giving it a position like 0, 1, 2, 3, we're going to give it the name of the key. So remember, the first part is the key, the second part is the value, okay? So if we put fruit colors, bracket, quotes, and then I put banana, or sorry, I said apple, but and then you press shift enter, it'll actually go in, check what is stored in beside the apple key and give you the value associated to it. Okay, so that can be really useful. So I'm trying to think of like a data example, but if you have like a ton of parameters that you're using for a model or something like that, you might want to have a dictionary where you store all your parameters and you say, this is the alpha value I'm using. What alpha value did I use for this model? Then it'll actually look it up and tell you that you use 0.5. whereas your other model, you might have used 0.6 if you store a dictionary for each of your models. I mean, there's a million examples of why a dictionary would be useful, but this is what basically it does, is that you can give a name to a value, and then you look it up based on that name. Okay, so there's a few other things you can do. You can add things after the fact, so like a list, you can also add to a dictionary. So if we do, and instead of replacing, it'll just we can add to it fruit colors. Use the square bracket again, and then I'm going to put lemon is equal to yellow. So when we've already made a dictionary, right, we had to use this notation when we were making the dictionary with the colons and the space, and with the colon separating the key from the value. But when you already have a dictionary, you can just tell it that in the key value of lemon, I want to give it the value of yellow. Okay, so now I'm going to run that, shift enter, and then let's look inside our fruit colors now. Print fruit colors. And at the end of the list, you see lemon is yellow. It's just like, it's as if it did basically the colon, lemon colon yellow for us, right? Okay, so let's just see how we're doing for time. Okay, that's good. So we know about different data types in Python now. We can start doing things that are a bit more typical of like programming logic, where we can check whether certain statements are true. And if they're true, then run some code. And if it's not true, then you might run some other code. This is where we start doing with like logic in programming. So we can start by understanding how we can test for logic, or test whether certain statements are true. And that is basically through things called Booleans. So I'm going to type out 2 and then the greater sign, right? That's the greater sign, and 1. So that says 2, this checks, if I run this, it'll basically say true, because it'll check whether or not 2 is greater than 1. And logically, we know that 2 is greater than 1, so it'll say true, right? But if we went back and changed it to the less than sign, it'll check whether this is true, and if it's not, then it'll say false, right? 2 is not, this statement is false, right? So these are called Boolean statements, and they can be useful for testing whether or not, like if you have a ton of data values and you only want to take the ones that are bigger than 5, you would want a list of trues and falses for that list or something. But so that's using the greater than or less than signs. We can also use test equality, which means, is this actually equal to are these two things equal? So if I do 1 equal sign 2 times 1, sorry, space 1, it'll say true. So notice that when we're testing for equality, we're using the equal sign, but we're using 2 of them. Just because if I do this, if I only put 1, it's going to put an error because you can't, it thinks that you're assigning a variable, because this is what we've used equal sign before for, right? But if you do 2, it'll actually test for equality. So it just tells Python that we're not trying to assign a variable right now. We're trying to test whether something is true or something is equal to something else. So you can even do this. You can put in brackets 2 minus 1, and I'll still say true. Because what it does, what it will do is actually inside, it'll evaluate each side, right, of the equal sign, of the double equal sign, and then it'll compare whether they're true. So on this side, 1 is 1, but on this side, 2 minus 1 is 1, which then compares to the other one, and that is true, right? But if I said 2 minus 2, it'll say false because 2 minus 2 is 0. It'll actually run that first, and then it'll say 1 is equal to 0, and it's false, okay? So this is, so now that we know this, let's just make for the next little bit, we just need to have an x value, like a random variable that we're gonna set to 5, just for this case. So do x is the name of a variable, and we're gonna set it to 5. Shift Enter to run that. And let's say, if I wanted to check whether X is an integer, I could use, if I happen to know ahead of time that maybe a variable should be an integer, I can test that by using the isInstance function. And then I will do X. And then this function takes two things. It takes the thing you're checking and the name and the type of data type you're trying to test whether it is. And I think it is an int. And if I press Shift Enter, that's true. It is an int. But now let's combine this into to test equality and use an if statement. So an if statement allows our scripts to have some more complex instructions where we're testing whether something is true, and if it is true, then you run some code. So that's what I was saying before. So we have x equals 5 already. I can use an if by just typing if like that, space. And then I'm going to use something that returns a true or false statement. So isInstance will always return a true or false statement unless you get an error or something. But typically it should return a true or false statement. So I can use isInstance x an int if x is an integer, which is going to be determined using this function. And then you need a colon, and you just press enter. And notice that it jumped in for it should be 4 spaces. It tabbed in, right? This is how we know that the rest of this code belongs to this if statement. We're going to say if x is an integer, how about we print the sentence x, x comma, and then quotation marks is an integer. So print is nice because you can print multiple things, and if you put a comma in between them, it'll automatically separate them by spaces. So first we're going to print the variable x, and then we're going to write the string is an integer. So let's just take a look at what this does actually. So just press Shift Enter. Everyone okay with that? So so you had a colon. So yeah, important things about an if statement is you have the word if, you have something that will return true or false to check whether something is true or false. And if it is true, it'll run the code that is below after the colon below that line of code, and it'll run this. So make sure you have this colon here. Make sure that you have the tab that the code is tabbed in. Okay. So what if we changed it such, if we go back to this line here, where we have x equals 5, change it to 5.0, which is not an integer, it's a float. And if I run isInstance x an int, it says false, right? So now if we run this code, what do you think will happen? Same code. What should happen? Nothing, exactly. Nothing will happen because this can only run if this returns true, right? If it returns false, it just skips over it as if it wasn't even there. But what if we wanted to do something when specifically it is false? Then we can use an else statement right after the if. So it needs to be, so you need to go back a few lines. So notice that this code needs to be tabbed in for 4 spaces. When you do an else, it needs to go back to the same level as the if it belongs to, okay? So you can think of this else as belonging to an if. They always have to be, they need to be paired up. You have the colon again to say that you're about to write a chunk of code. And then again, you press enter, it should be tabbed in, and we'll say x is not an integer, okay? And if we run that, then it says, so if we think of the logic of what happened, it first went here and it said, is this true? Is x an integer? And this returned false. So then it jumped here, it didn't even look here. It jumped to the else, and then it said, and it ran this code instead, okay? So that's useful if you have 2 options of things that could happen. But what if things are a bit more complicated? What if you have multiple scenarios that could happen? It's not just binary, it's not just yes or no. We can start doing things called if, else statements. Let's just make one just because we'll add it to this one. So go here and Let's press enter, go back to the beginning of the line, line it up with the if, and then we need to do an elif. Notice that these words bold, like as I'm typing it, it's like looks normal, but then suddenly when I type elif, it bolds to green. That just means that these are words that Python recognizes as special. So elif has a specific meaning in Python, right? So just so you know, when you're using words that belong to the namespace in Python, you don't want to, like, for example, name a variable elif, because that would mess things up. Just so you know. Okay. So again, you have elif, which means else if, basically. Don't put a colon there yet. Erase that. Is instance, and we'll do x, comma, string, so we can check if it's a string also. So things just aren't integers or not integers. They can be strings. They can be lists. They can be dictionaries. But for now, let's just look at int, string, and else. And then you have a colon. Press enter. It's tabbed in. Then we're going to say if it is a string, then you want to print x is a string. Okay. So to run this, same thing should happen because we haven't changed our value of x. It's still a float, which is neither an integer nor a string. But what if we change x to, just make a string like dog. Run that, then run this. Dog is a string. That makes sense? So you can imagine having multiple elifs, right? So the structure of an if, elif, else statement is that you always need to start with an if. You can, and all the rest are optional. And you can have many elifs, but you cannot have many elses. So the only thing that there can be multiple of is the elif. So if we can do elif is instance x, and we can do list, for example, and then do the same thing, print x is a list. Okay. I won't go any longer with this, but basically the idea is that you can have multiple options of different cases in your code where if this is the case, then do this, whereas if this is the case, then do something else, right? And then you don't have to manually hard code that every time. It's in the code, and when you run it over different data sets, it should be able to notice the difference and then do different code depending on what the scenario is. Okay. So next thing that's important for programming is the concept of a for loop. So imagine you have multiple items and you want to do the same thing to each of those items, but you don't want to write the code like a million times for each of those items. Say you have a list of 1,000 rows of patient data, and you want to parse out the data and get like the mean, let's say, heart rate over 20 days for each of those patients. You don't want to have to write the code for every single 1,000 lines. You want to make a code for the first line and then have that apply to every single one of those, right? Here, the concept is using a for loop. We won't always use for loops when you need to apply these things to multiple things, but it's good to know the concept. So in a for loop, we always have something to loop over, something that has multiple items in it. So we're going to make a variable called nums, and we're going to put nums is equal to, and then we're going to make a list, just a simple list of numbers, 1, 2, 3, 4, 5. Okay, shift enter just to get that. So what if I wanted to check whether each of these numbers is even? So one thing I'm just gonna, as a side, you can test whether something is even, a number is even, by using, I'm just gonna access the first item first by nums. This is the first item, which is 0. And you can use this %, which is called a modulo in this case. So what that basically does is it divides this number by 2 and it returns the remainder. So let's just print that. So if we divide 1 by 2, the remainder when you do the division should be 1. So if you have an even number, so if we do the second number, it should be 0. And if we do the third number, it should be 1 again. So that's a quick way, that's a simple way that often you would check whether an item is even or odd, is by doing the modulo of 2, because the remainder will always be 1 or 0, right? So that's just an aside. But what if we want to do that for each of these items? And I could go in and type these each time, like 3, 4. But you can run a loop also to do that for every single item. So this is what a loop would look like. So for, you write the word for, and again, it lights up because that's a known word in Python. And then I'm going to put for every number, and so this basically says for number in nums, and this is called a dummy variable because it actually doesn't matter what you call this item right there. It's just for Python to know to use that item, to use that name in each time you're working on each of those items. It's temporary store for the item in that list. So let's just actually take a look. So for number in nums, colon, this is the format. You start with for, dummy variable in, and then the thing that has multiple items, which is called num, or list nums. We're going to check. We're going to combine this with our if statements. If number, sorry, modulo 2. Remember, we're checking if it's even or odd. So if it's even, modulo 2 should return a 0, right? We put a colon, and then we'll print number, comma, space, apostrophe is even. So it'll print out the number, and it'll also say is even, but only in the case where modulo 2 is equal to 0, right? If we wanted to do odd, we would do modulo 2 as 1, right? But in this case, we're just going to do even. So let's run it, and you should get 2 is even and 4 is even. And that's correct. Like logically, we look at it and that makes sense. And you can imagine if you had a huge list, all we had to do is write 3 lines of code. And this could work for a list that's size 5 or size 2 million. The same amount of code will work for the same size, for different size lists. It's just that the output will be different, of course. So I think this is an important thing to note is that I could change this to X, but every time I'm representing that value in the code chunk, you need to change that value to match as well, okay? Because that's how Python knows that what exactly are you applying this code to. You're applying it to the X, which belongs to nums, right? So if I run that, it'll be 2 is even, 4 is even. And if you can actually take a look at what is inside X at the end, and X will be the last number, because as it's going through, X is taking on the value of items in the list. So the first time, X is 1, and then it loops again, and then X becomes 2. And then it loops again, and X becomes 3, checks whether it's even or odd, prints it out, or it doesn't print out because it's odd. Then X becomes 4, and then X becomes 5. That's why when you print X at the end of a loop, it's going to take on the last value, right? It's a dummy variable, meaning X doesn't need to have an interesting name, but it's always good to have just like informative names, right? So this is actually a number, so I might as well call it a number. And notice if I keep this as X, X never changed, right? Because it was from before 5, whereas here we're using number. So I just want to make note that if you ever are changing the names of your for loop dummy variable, you need to change it in every case it comes up, okay? All right, so the last thing I want to cover, I don't think we're going to, the last bit is going to be on functions. And then right after that, I'll do a quick demo on some important packages that are often used in Python in science, but you don't need to code for that part. So let's just try to get through the functions part, and then you can just kind of sit back and watch the last bit. Okay, so functions are like print is a function. It does something, it takes in an input and it does something with it. So it took in the X, it actually evaluates it and gives us what was stored inside, right? Or it prints out whatever it was. But we can make our own functions, right? Often that's what we're doing when we're programming, is writing functions that are specific to our needs, not always just using other people's functions which are already in Python or in packages. So functions allow us to to store a set of instructions that you do with an input inside a variable name, which is a function name, and then lets you apply it multiple times. Just like, yeah, so actually let's just do an example. Let's do x, make some variables, x equals 5, and then press enter. Within the same box, I'm gonna do y equals 7. So every line is evaluated separately. So let's run that. And if I wanted to get 5 squared, imagine I needed to square x and y and then add that together, the squares of each. I could do that by doing print. I'm going to use 2 parentheses here. X to the square of squared by squared. I'm going to add that to, and then another set of parentheses, y squared, right? So x squared plus y squared each have their own brackets matched up, all in one set of brackets for the print function. You get 74. Everyone get 74? Okay. But what if I have multiple pairs of numbers that I need to constantly do that same operation with? You could do a for loop where you're putting it in, where you're doing that multiple times using the same code, or you can just put it inside a function so that the next time you need to do that, you can just call the function just like you would call a print function. Okay, so this is how you define a function. So I'm just going to make some more space so you can see it better. So how you define a function is you write the word def for define, and you need a space, and then the name of your function. You can name it whatever you want. Again, you want to be very informative. So we're going to call it the sum of squares. Names of functions, similarly to variables, can't have spaces in them, can't start with a number, I think, things like that. So same rules apply. And then you need a set of parentheses to tell it what the function will take as input. And it will take an x, or num1, and comma, num2. So again, these are sort of like dummy variables where the name of these don't really matter. It's just to keep consistency within Python when you're doing different things with it, with these values, num1 and num2. So I'm going to put a colon. So these are the components. You have the def, space, name of the function, no space, these parentheses, the items in which it'll take, the names of the arguments is what they're called, and then no space, a colon. Press enter right after the colon, and it should, again, tab in. And then we can start doing something with those items. Let's call it the sum squares out. I'm just going to name that for now, but we'll see why I'm doing that, is equal to num1 squared, right, plus num2. So in this case, I could put brackets again around it, but because it follows the rules of order operations, we don't really need brackets here. So this should give you the square of this, and add it together, and we store it inside that. And something that we have to do in functions is we need to explicitly say what we're going to send out of the function. So it's called returning, return. And we're going to return the ss out. Okay, so that means when we call this function, so we've defined it here. This tells it what to do. When you call this function, it'll actually do this to the 2 different numbers you give it, and it'll return ss out. Okay, so let's just shift enter to save that, or to execute that. And let's try using it. So I'm going to print s sum of, and I'm going to stop there and tab, and it should autocomplete. That should work for you guys too, right? That's just a nice little tip, because if you have like these long variable names, it's hard to type out accurately. You might make typos and stuff, so I like to use tab complete. So I'm going to show you that again. I'm going to start with a few letters. If I start with S, I might have lots of things that start with S, right? But then if I do S like that, it'll show me a shorter list, and eventually it'll only show me the ones that I care about. And if I do enough, it'll just do the only option that is available. Anyways, that's just a useful tip. So if I do sum of squares, if I'm calling sum of squares a function, you need to have brackets to input something to it, right? So I'm going to give it 1, just keep it simple. The first number is 1, the second number is 2. So it needs to get two numbers, right? It needs to get num1, num2. And in those places, I will give it two numbers. And it'll tell me it's 5 because 1 squared is 1, 2 squared is 4, 1 plus 4 is 5, right? So it does that equation for me. And I can do that with different numbers now. Sum of squares 4 and even 5.5, I think should work, right? So now you can, you have this function that you can use over and over again, and you don't have to write it many times. And it's not always that you need to use it in a for loop, so you don't need, so a for loop has a specific function for reusing code, writing it once, but functions are more when you just need to here and there use the code again, and you don't actually know when you're going to need it, but you know that it's useful. You would write a function. Okay. So does anyone have questions generally about a function? Oh, also one thing to note is that this is how we write a function, right? That's all you really need. But what can be useful is if you have 3 quotation marks, right? And write inside of it some instructions for the person, for yourself, right? For future you, and for the person who's going to look at your code maybe in a month just to use your code. So what you can do is say sum of squares you can write like a note to yourself, basically saying returns the sum of squares for 2 numbers. So this is how, like, everyone has different styles of writing these notes to themselves. These notes are called doc strings, like documentation strings. But I like to put a little summary sentence, and then other people will kind of put like input is going to be num1, which is a int, or which is an, I guess, int or float or something, a number. And then you can say first number, num2 int. I mean, in this case, this is a very simple function, so you don't need to actually really write all this because you can probably just look at your code and figure it out. But imagine you're writing a really complicated function where you forgot why you did all these things. It's really useful to have these. And it's going to output I guess you can call it a number, returns the SS out, which is, okay. So so if we run that again, so if you had 3 quotation marks at the start, 3 quotation marks at the end, if I did help sum of squares, I actually don't know if this will work. Yes, it should print out your doc string that you wrote. Okay, which is kind of useful because you may have like written your code a long time ago and you might not remember all the details about it. Okay. So for this next part, I'm just going to run through some examples. So you can write it all down, but it's also all online. You can either watch this video again or check out the Jupyter Notebook online that under the lessons for Intro Python, and it will all be there. It'll be the same. So what I'm going to do is import a package. So a package is a set of functions or code that someone else wrote that is not in base Python, because they thought it would be useful for other people who probably have the same problems as them. We don't always need to reinvent the wheel and write a sum of squares function, right? Someone has probably already written a sum of squares function or whatever functions you can think of. Often someone has probably already written it. So for example, there's a Python package called Numpy, numerical Python, or Numpy as NP. So I can import it like this, import the name of the package, and then I can give it a nickname so I don't always have to call out the full name, because how I access functions within Numpy. Oh, also I'm at 7:10, so if you guys need to go, this part I will just kind of quickly go through, but if anyone needs to go right now, we're good for like another 5-10 minutes. Okay. So I'm going to import this package as NP. I'm going to run that. And that took a bit of time because there's a lot of functions in NumPy. And so these have like useful functionality. Specifically, NumPy is for doing like numerical operations on basically these NumPy arrays or like vectors. So let's take a look at what that means. So let's call this a NumPy array. And we're going to set it to NP, make it an array. And we're going to give it a list of numbers, 1, 2, 3, 4. And it's going to turn it into an array. So it doesn't say list anymore, right? This should have been, this was a list, but when we do NumPy array on it, that's a function, it turns it into a NumPy MD array. What's cool about these arrays is you can, remember when we had lists? So I'm going to make two, let's do just normal, let's say normal list equals 1, 2, 3, 4, just to have a comparison. So if I do NumPy print NumPy array times plus NumPy array, it'll actually do a vectorized addition of these arrays, which is probably more useful for us than if we did the list addition, which is, if you remember from very early on in this lesson, if we added two lists together, it kind of just appended them, right? Like that's not numerically, like, depending on what you need to do, that's not really what you want sometimes. So if you do want to concatenate some lists together, that's useful. But if you actually just want to add them together, then you can use NumPy arrays, okay? And same thing with multiplication. It'll do a vectorized, like on each item, you can do NumPy array times 2, and it'll do 2, 4, 6, 8. You couldn't do that if it was a list, right? You would have to write a for loop that would have to loop over each one and then multiply it by 2 and reassign that item, okay? So this is just like very quick ways to do these simple things. You can do things like NumPy array, and it has the method, which is sort of like a function attached that only works for this item called, so there's a method called mean that works on the array, and it gives you the mean of the values. So really simple statistics, right? You can get the median as well, I think. Oh, maybe not median. Is it? No, it doesn't have median, but I think you can get mean, max, get the min, right? It's like simple things like that. There's a ton of others. I think you can even get the variance. Yeah, you can get the variance as well. And like you can look through all the things that it can do by doing this. Oh, whoops, NumPy array dot, and then you do the dot to let it know you're about to start looking for methods, and you press tab. Remember how before tab is like for autocomplete? It shows you the list of all the things it can do. And if you're curious about what these things do, you can go look it up, or you can actually just do the help function as well on these. Okay, so you get like say max, mean, min, tell you, it can do a lot of things. So if you were curious what it could do, you could just use that. Also, one thing I want to show is quickly how easy plotting can be in Python, especially if you're working with kind of like these Excel data frames. If you were to import a data frame, you can often use pandas as a different package that is good for that. I'm going to import that. I'm also going to import a plotting package called Seaborn as SNS. So like, don't try to remember everything I'm showing you here, just to know that things are possible, and then you can go take your time to look them up later. So first thing I'm going to do, just wait, I need to matplotlib inline. This is kind of not that important. I think if you installed this recently, you shouldn't have this issue, but that's just to make sure all the plots show up within this Jupyter notebook. I'm loading a data set called Iris. It's very commonly used for data, explaining some data function, data science type concepts for people. So Iris is a data set with flowers, iris.head. So pandas, you can imagine that Iris was stored as like a CSV, and then when it read it in using Seaborn, it's basically like a table. So these are the columns, which are aspects of the flower, like sepal width, petal length, petal width, and the species. And it tells you the different species of flower. Anyways, that's not so important for us. We're not trying to work on this data set right now. I wanted to show this basically just so that I could show you that we could do some interesting things with, let's say we wanted to extract only the first 2 rows of only the petal length. So you can get, for the first 3 rows, I can get just the petal length values. So you can like index and slice in these Excel, like these data frames anyways. And we can plot with them too. So if I did SNS rel plot, this is, so what I want to do is plot the petal length of these flowers against the petal width. Like maybe there's a relationship between petal length and petal width, right? The bigger your petals, the wider your petals, maybe they're also longer. We want to just see data equals iris. Oops, sorry, I spelled that wrong. And you get this nice plot, super quick in one line that plots all the different values of petal width and petal length from that data frame. I'm going to copy and paste this, and I'm going to change it so that I'm going to add this one little argument that says color them depending on their species. So remember, if we look at the list at this data frame, it tells you the species. And if we actually look at, let's do 20. Oh, they're all in order. Okay, let's do tail. Sorry. So there's 3 different species. So I think Setosa virginica. I never remember what the last one is. But there's 3 species, and if I were to color them by species, it will do that. Oh, there it is. Verticolor. So then all I did was change one argument, and you can get these nice faceted, is what you call, not faceted, yeah. But anyways, you get these like individually colored data points, and you can imagine that you can do this with different types of plots as well. You can do many different plots using Seaborn. I'm just showing you kind of one that was easy to visualize and understand, but that took the same line of code with like a few more characters, and you can change it completely, right? And you can also change like the size of your plot and stuff. That is probably for another lesson, maybe not even this semester, but yeah, this is really easy to make these plots with if you have a data set that you want to play around with. I think by the end of this lesson, I think you should get a sense of what the language of Python sort of looks like, the kind of things that are important and not important. So white space matters sometimes when you're making for loops and functions, you need an indent, right? But the space in between things also matters just to separate, make them clear, but sometimes it doesn't matter. And yeah, there's a lot of useful packages out there that you don't need to reinvent the wheel to do your data analysis. There's many packages out there, you just need to look up online for tutorials. Okay, thanks, that should be it.